Causes of ice ages. An ice age is a long interval of time, from millions to tens of millions of years, when global temperatures are relatively cold and large areas of the Earth are covered by continental ice sheets and alpine glaciers. Within an ice age are multiple short-term periods of warmer temperatures called interglacial cycles, when glaciers retreat, and colder temperatures called glacials or glacial cycles when glaciers advance. At least 5 major ice ages have occurred throughout Earth's history. The earliest was over 2 billion years ago, and the most recent one began approximately 3 million years ago and continues today. One significant trigger to initiating climatic fluctuation, and hence ice age, is the position and movement of the Earth's plates. The position of a continent affects its climate. Land masses at high altitudes and latitudes are more likely to be cold and provide the conditions for glaciers to form. During the current ice age, which began slightly less than 3 million years ago, several large land masses that contained extensive glaciation have been at high latitudes, including Antarctica and much of North America and much of Eurasia. Plate tectonics probably contributes to the development of long periods with many glaciations in another, more subtle way. Plate movements sometimes cause the uplift of large continental blocks, which can cause profound changes in the global oceanic and atmospheric circulation patterns. When the warm water flowing from the equator to the poles is blocked or reduced, ice sheets may arise and set another ice age in motion. Today's ice age most likely began when the land bridge between North and South America, Isthmus of Panama, formed and ended the exchange of tropical water between the Atlantic and Pacific Oceans, significantly altering ocean currents. Although not their primary cause, atmospheric gases also play an important role in the ice ages. When greenhouse gases such as carbon dioxide and methane are abundant, they trap energy and keep it close to Earth, thus keeping the planet warm. Yet, when these gases aren't present, the radiant energy escapes. Antarctic ice core data show that CO2 concentration is low in the cold glacial times and high in the warm interglacials. Other atmospheric changes are also likely in play. Studies indicate that there may have been unusually high amount of dust in the air during the Pleistocene ice age, which would have blocked the sun and kept the Earth's temperature cool. Similarly, ashes emitted into the air during volcanic eruptions can interact with water vapor to produce certain chemicals which scatter the sun's radiation and prevent it from reaching the Earth's surface. It does appears that periods of intense volcanic activity preceded glacial ages. Fluctuations in the amount of insolation, that is, the incoming solar radiation, are the most likely cause of large-scale changes in Earth's climate. This solar variable was neatly described by the Serbian scientist Milutin Milankovic in 1938. According to him, there are 3 major components of the Earth's orbit about the Sun that contribute to changes in our climate. For one thing, Earth's rotational axis, which is believed to tilt at about 23.5 degrees from vertical, in fact oscillates between 22.1 and 24.5 degrees on a 41,000-year cycle, and the difference between summer and winter temperatures increases as the tilt becomes larger. For another, the shape of Earth's orbit ranges from nearly circular with an eccentricity of 0.005 to slightly elliptical with an eccentricity of 0.058 and back again about every 100,000 to 400,000 years. When the orbit is nearly circular, the distance between the Earth and the Sun, and therefore the amount of solar energy reaching Earth, remains relatively constant. However, when the orbit is more elliptical, the distance fluctuates, resulting in slightly warmer or cooler temperatures. Finally, Earth's axis of rotation behaves like a spinning top that is slowing down, wobbling in a circle over time. As a result, the position of the Earth on its elliptical path changes relative to the time of year, a phenomenon known as the precession of equinoxes. The cycle of equinox precession takes 23,000 years to complete. These regular variations, the so-called Milankovitch cycles, have proved to play a major role in the occurrence of major glaciations in history.